Alright, folks, now let's look at our ambiguous case. So this is the case of SSA. Now, there are three different cases that go with this one case. SSA can either be no triangle, one triangle, or two triangles. Okay, depending on the data given. Okay, so we'll introduce those as we go through them. All right, so let's look at this first triangle. So what we want to do, find beta given alpha is 34 degrees, B is 2.3, and A is 1.2. Alright, so find beta. Well, good news, we have alpha and A. We have little b, so we can find beta. I mean, our law of sines, we can use it very easily just like so. So since we know 3 and only have one unknown, we should be able to find beta. So this is the sine of 34 all over 1.2 equals the sine of beta all over 2.3. Okay, so solve for sine beta. So sine beta is going to be approximately 1.0718. Approximately. Now, here's the problem. What do we know about sine and cosine? What's the largest they can equal and what's the smallest they can equal? Well, sine and cosine have to be between -1 and 1, right? So, look, this is greater than 1. So, because of that, we would say no triangle. Now, you would be able to find this very easily if you didn't recognize it and you went ahead and tried the inverse. I know when I do that in my calculator, it says domain error. Okay, so you're going to catch yourself even if you get ready to, because if this was a solvable triangle, we would use the inverse just like we did here to get angle beta. But we can't because 1.0718 is greater than 1, which is not feasible with sine or cosine. So there's no triangle would be our answer. No triangle would be our answer. Now, one thing you want to know is what is wrong with this? Well, think about it. They gave us alpha is 34 degrees. B is right here. This would be C. So A would be opposite of alpha, so it would be 34. Now 1.2, no matter which way you swing it on this pendulum, 1.2 is not going to connect and make a triangle. Okay? 1.2 will not connect and make a triangle. So what we generally say there is since alpha here is since alpha is less than h. Now what is h? Well, what you can do here is you can also use the formula that we derived in the beginning. We said H is B sine alpha, right? So if you were to do 2.3 times the sine of alpha, if you would do 2.3 times the sine of alpha, you would get 1.29. You would get 1.29. So, because this is an acute angle, here, angle alpha, and because A is between 0 and H, A is greater than 0 but less than H, because of that, there is no triangle. Now, these are all ways to get to the same conclusion. Now, this, I will want to see work, so this is what I mean by showing work, okay? This will be the way you can catch it, okay? That's the way most people do it, is the worked out way, because it's easier to catch than trying to draw some triangle that you're really not sure what it's doing, okay? It can, I don't trust human error when drawing that triangle, okay? All right, so you'll catch it when you get down to solving the angle. No triangle. Well, let's look at one that has one triangle. Okay, still SSA, it's still the case of SSA, but this is going to be the one triangle case. So let's say alpha is 47, A is 3.7, and B is 3.5. Now, I want you to keep this in mind, folks. Look at what we have here. If we were to draw this like normal, alpha, beta, gamma, A, B, C. Notice what we have here. It's two sides and a non-included angle. Two sides with a non-included angle. With a non-included angle. Now, the reason I tell you that is your book is using alpha, 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 alpha all the time as the angle. We could use gamma, we could use beta, as long as it's a non-included side. For instance, this problem here could very easily be written, gamma is 47 degrees, then you would have alpha is 3.7, C is 3.5. Does that make sense? Gamma, alpha, C, beta, C, B. You could very easily substitute those letters in. So I say that because some students get hung up on the alphas I'm writing here, because that's what your book uses, and they think, oh, it has to be alpha. And so when we throw up a beta and a C and a B up there, people get all frustrated. You've got to be able to manipulate, okay? Remember, that's the key to this class, manipulating the formula. So it's a theory. It's a concept. It applies for all of them. It's just when you have two sides and a non-included angle. It could be any of them, okay? So keep that in mind. So, again, let's solve this whole triangle here. So the directions would be solve the triangle. And I know that doesn't look like a triangle, but it is. So we have alpha and A, and we have B, so we can solve for sine beta first and foremost. Alright, so go ahead and plug in your variables. Now, there's no reason I switched that up. That was just me thinking, okay? So don't think I'm switching that up for any reason. All right, so sine beta equals 3.5 times the sine of 47 all over 3.7. Okay, that's what sine beta is. Now, how do we find beta? That's our goal, is to find beta. Well, this is where we do the inverse. So using your calculator, do the inverse. Just like so. Okay? And what you'll come up with is 44 degrees. 44 degrees. Now, remember with an inverse, typically there's two choices, right? Typically, if you remember your unit circle, here's 44 degrees, somewhere right in here. So remember, there are two choices that will give you the same sign. That other choice, if you remember from our inverse section, is where? The other choice is right across right there. So there are two choices here that give you the same sign. So how do we find that other choice right there? Well, this distance and this distance are the same. So to find that other choice is 180, because from here all the way around to here, all the way around to the axis over here, okay, that's 180 degrees. So since these two distances are the same, 180 minus 44 will give you this other angle right here. So that's 136, or 136, because remember, it will give you two angles when you do those inverses. Now, here's what you have to do. Do a quick mental check here, okay? Do a quick mental check, because I told you this is only a one triangle problem. Well, we've got two triangles here because here's two different values for beta. So that's going to give you two triangles, right? Just a second. 47 and 44. Okay, that's 91. Okay, so we're good because that's less than 180. A triangle has to equal 180. So if we add these two together, they need to be less than 180. Well, 47 and 36 and 136. So if I do 136 and 47, what do I get? Well, I get 183. Well, now that's not possible, because a triangle can't be 183 or greater. It can't be that. These are only two angles. So there's another angle to throw in there. So it's going to be probably close to 200. So you can't have a triangle like that. A triangle can only equal 180 degrees. So this particular angle right here that we found does not work. So that's why we only have one triangle, because of this right here. Now, what would happen if this had come out? Let's say this 136 had made this right here come out to be 120 degrees. Well, that would mean we had two separate triangles, so we would have to solve two separate cases. Now, I'll show you one like that here in just a moment. But keep in mind, that's the reason that one doesn't work. Don't just write 44 down, because 136 might work. You have to test it with the given angle to make sure. Okay? So that was greater than 180. It didn't work. So that's why we have one triangle here. So think of what we have. We're solving the triangle. So alpha, beta, and gamma, and A, B, and C. All right, so A is 3.7. B is 3.5. We know alpha is 47. We now know beta is 44. Well, what is gamma? Well, hopefully now we know two angles, so hopefully you realize what we can do here. So subtract 47 and 44 from 180. When you do that, you should easily get your gamma to be 89 when you subtract 47 and 44 from 180. Now what happens? Now we just have to solve for side C using our law of sines. So sine alpha over A equals the sine of gamma over C. So that's going to be the sine of 47 all over 3.7 equals the sine of 89 all over C. And so figure out what your C equals, just like we did in previous problems. And so C comes out to 5.1 because we're doing two significant figures here. So 5.1. So we have solved this triangle. Now it's at this point right here when you check these two answers that you get for the angle. Don't forget, two answers for the angle. When you check those two answers, that's where you determine if it's going to be one triangle or you determine if it's going to be two triangles. Excuse me. So, for this particular problem, we are done. Hopefully it's understandable. Now, the only other one, we have one other SSA rule. And so the last case of SSA is when we have two triangles. So alpha is 26 degrees. A is 11. And B is 18. So alpha, beta, gamma. Let's solve this whole triangle here. Now we've already been given 11 and 18 here. We've already been given alpha here. Alright, so just like the last problem, let's solve for beta. So the sine of alpha over A equals the sine of beta over B. So that's the sine of 26, excuse me folks, sine of 26 over 11 equals the sine of beta over B. Get me a cough drop here a second. Alright, so just like, now B we actually know, I don't know why I wrote B. So B is 18. Now, alright, sorry for the coughing. Now with our cross multiply and divide and figure out, do your inverse and figure out what sine B is. So we know B is going to be the inverse sine of 18 times the sine of 26 all over 11. Once you cross multiply and divide, take that inverse to find beta, remember. Just like we did last section. Now you're going to be using your calculator for this. And notice we're all 2 significant digits up here. So round it to 2 significant digits, and it should be 46 degrees. All right, same bit of info here. We have 46 degrees is right here. So that means we have an angle. We have another angle somewhere on this unit circle. Now, because it's sine, we know it's right here. We have another angle that would give us the same sine value, just like we learned with inverses. Now again, because this and this are the same, and the distance all the way around here is 180, we can subtract 180 and 46 and get this angle right here. So 180 minus 46, okay, 180 minus 46 is 134. So this particular angle is 134 degrees. So it's either 46 or 134. Now remember, we have to check this. We have to check to make sure that we have to check to make sure that we are not above 180. So 26 and 46, if we add those together, those are obviously not greater than 180. 26 and 134, well, that's 160. So that's not greater than 180. All right, so neither one of these, if you add it to alpha, are greater than 180. Uh-oh. What does that mean? Well, that means we have 2 triangles, because not only 2 possible triangles here, because not only is 46 beta, but at the same time 134 is also beta. 11, 18, 26, 134. Now I'm going to call these over here, I'm going to call these primes: alpha prime, beta prime, gamma prime, A prime, B prime, C prime. I do that so that we can keep the triangle separated and know the difference. Alright, so now here we go. We have 2 triangles because these 2 are both less than 180 when we add it to alpha. Alright, so how do we find out what gamma is? We'll subtract the 2 other angles from 180. So 180 minus 26 minus 46 gives us 108. Okay? And we have 180 minus 26 minus 34 gives us 20 degrees. Okay? So we solved that very easily for gamma and gamma prime. Alright, so now we got to find C and C prime. And we do that with our law of sines. So, the sine of alpha over A equals the sine of gamma over C. So plug in and you will have the sine of 26 all over 11 equals the sine of 108 all over C. So C equals, cross multiply and divide. All these are to 2 significant digits except for 134 and 108, so just go ahead and keep it as 2 significant digits for this particular one. Anytime it's rounded to the degree like this, we're going to try to keep it 2 significant digits. It's when we start getting into tenths places and things like that that we're going to do more significant digits. Typically, the rule of thumb is this. If we're rounding to a degree, we try to keep it to 2 significant digits. If we're rounding to a tenth of a degree, 3 significant digits. If we're rounding to the hundredth of a degree, 4 significant digits, and so on. Now, all that info that I just stated is on page 351 in your book, and in table 1. You can look at that, turn over there and look at that. But try to round this to 2 significant digits. So when you do that, you should get 24 for C. So there's 24. Now, the largest side should be with the largest angle, and it is. So that's absolutely correct. So now let's do the same thing again. The only difference is this time we're doing it for alpha prime and A prime and gamma prime and C prime, so that we can find this other angle. So that's still the sine of 26 all over 11 equals the sine of 20 all over C prime. So 2 significant digits again, cross multiply and divide, and you should get 8.6. And now, folks, you have solved for both triangles for the ambiguous case. So that's the hardest problem of all of them, okay? When both of our inverses here, when both inverses happen to be less than 180 when added to the original angle, then we have 2 separate triangles we have to solve for. Make sure you remember that, okay? And also, I can't stress enough, please, 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 folks, I can't stress enough that make sure, please make sure that please make sure that you realize that it doesn't have to always be alpha, A, and B. As long as it's 2 sides and a non-included angle, we can use the same methodology, the same theory to solve them. It's just got to be 2 sides and an unincluded angle. We used alpha, A, and B the whole time just to kind of be consistent. But realize it can be any version of these angles and sides as long as it's 2 sides and a non-included angle. So now for the ambiguous case, remember you're going to have either 0, 1, or 2 triangles. Now you really don't have to, if you solve it out like we did, you really don't have to memorize conditions, because the way I taught you to solve it is the derivation way, so that you can derive this on your own. You don't really have to memorize any kind of conditions to tell the difference between 0, 1, and 2 triangles. However, if you're a condition person, page 359 in your book, table 2, has the conditions. Note that each condition compares, and this is where you would want to pause, of course, and go get your book if you don't have it with you right now. But page 359, table 2, this is where each condition compares 2 or more of A, B, and H, where A and B are the given sides, and H equals B sine alpha. Alpha is the given angle, which is opposite side A. Now, notice if you look in that table, again, they use alpha as your starting angle in your book. It doesn't have to be alpha, remember. It can be, as long as it's As long as it's an angle and an opposite side, basically, is what they're talking about there. Two sides and a non-included angle, remember. You're fine. Now, these are all the conditions in that book, in that table. The bad part about trying to memorize these conditions is that they can be very confusing from time to time. Okay? Very confusing. So, so what I would do is I would learn to do it this way, where you don't have to memorize those conditions and memorize a whole new way of thinking about it. And it involves a lot of you knowing where to put things in a triangle if you're going to use the conditions. Here, notice with this problem, I never drew either triangle. Not necessary. Okay? Not necessary to draw it. So, keep that in mind as you're using this. And also keep in mind that you'll have some application problems like this, but they're solved the exact same way. Now, with an application problem, unless they give you the angles, okay, you will need to draw the triangle for application problems, just so you have an idea of what the opposite angles are, okay, what the angle and the opposite side are, so that you can use the law of sines to solve. So you'll need to draw it for application problems. But for one like this, you don't necessarily have to draw it, okay? Keep that in mind. If you have any questions on section 6.1, please feel free to ask. 6.2 video will be coming up very soon.